All right, so now that we talked about limiting reagents and excess reagents and how to find those, the last thing we need to talk about in order to move on to our next topic is what is a percent yield. So there's three terms that we need to have to talk about when we're doing a limiting reagent problem. So the first one is called the theoretical yield. Now, we've been dealing with theoretical yields. I just haven't been calling it that. So the theoretical yield, this is the amount of product that's formed, that should form if all of the limiting reagent is used up. So this is the amount of product that is formed when all of the limiting reagent is used up. Okay, so again, that's assuming that all of the limiting reagent is completely used up. Okay. Now, a lot of times, though, when we do a chemical reaction, a lot of times it's not going to be 100%. So while we have a theoretical yield, we have another term called the actual yield. So the actual yield, what this means is that this is the amount that's actually obtained from the chemical reaction. All right, so theoretical, this is how much you should make if everything's working properly. Actual is how much you really did make. Okay, so if you have the theoretical yield and the actual yield, then the percent yield is actually describing the proportion of the actual yield to the theoretical yield. So the way we calculate the percent yield is that we take the actual yield divided by the theoretical yield, and then multiply that by 100%. Okay, so let's try a problem out using everything that we talked about. Converting from grams to moles, molar mass, limiting reagent, excess reagent, percent yield. Let's put it all together and see what this kind of a problem looks like. Here's our next problem. Industrially, vanadium metal, which is used in steel alloys, can be obtained by reacting vanadium 5 oxide with calcium at high temperatures to give us this equation. 5 moles of calcium plus V2O5 yields 5 moles of calcium oxide plus 2 moles of vanadium. In one process, 1.54 times 10 to the third grams of V2O5 react with 1.96 times 10 to the third grams of calcium. Part A, calculate the theoretical yield of vanadium. So this tells us right off the bat that vanadium is the product of interest. So let me put a box around vanadium. All right. So part A, calculate the theoretical yield of vanadium. Part B, calculate the percent yield if 803 grams of vanadium is obtained. All right. Okay, so there is, again, just like the last problem, there's one question that's actually being asked before we even get to part A, and that is to determine the limiting reagent. All right, so we've got 3 questions to ask ourselves in this problem. First off, what's the limiting reagent of this reaction? Part B, calculate the theoretical yield of vanadium, and then part C, calculate the percent yield if we know the theoretical yield of vanadium. All right. Here we go. So let's try to tackle the first question, the limiting reagent. All right, so we're told that we have 1.54 times 10 to the third grams of V2O5. So let's start with that. 1.54 times 10 to the third grams of V2O5. All right. All right, so we need to convert this from grams to moles. The molar mass for V2O5 is 181.88 grams of V2O5. And so I put that on the bottom, 1 mole of V2O5 on the top, so that way the grams of V2O5 cancel out. Now we need to convert from V2O5 to moles of vanadium. So I'm going to use the stoichiometric coefficients to help me do that. So we've got 1 mole of V2O5 under 2 moles of vanadium. So that way moles of V2O5 cancel out. We're in moles of vanadium. And if we do this, if we multiply 1.54 times 10 to the third times 2 divided by 181.88, the number I get is 16.93 moles of vanadium. All right, so let's try the other one. So we're told we've got 1.96 times 10 to the third grams of calcium. Let's do that. 1.96 times 10 to the third grams of calcium. We need to convert this from grams to moles. So we need to look, since it's just the elemental form of calcium, we just need to look up the molar mass of calcium on the periodic table, and that number is 40.08 grams of calcium. Okay. All right, so that way the grams of calcium cancel out. We're in moles of calcium. So now, according to the chemical equation, we need to go from moles of calcium to moles of vanadium. So we have 5 moles of calcium under 2 moles of vanadium. So that way moles of calcium cancel out. So this is going to be 1.96 times 10 to the third times 2 divided by the product of 40.08 times 5. And so that number that I get is 19.56 moles of vanadium. So according to this problem, since V2O5 produced the least amount of vanadium, what we can conclude is that V2O5 is the limiting reagent. All right, so the first part, now that we answered that first question, the second question is, what is a theoretical yield of vanadium? Well, we know, to answer that question, since we know that 16.93 moles was produced, okay, if we convert this from moles to grams, 1 mole of vanadium underneath, that molar mass is going to be 50.94 grams of vanadium. 16.93 times 50.94, that should give us about 862.4. So we got to report this with the right amount of sig figs, so this would be 862 grams. All right, so that's part A. Now, part B, and again, keep in mind, that's the theoretical yield. Okay. Now, part B is asking, calculate the percent yield if you obtained 803 grams. So the actual amount that we made for this reaction was 803 grams of vanadium, but we were supposed to make 862 grams of vanadium. All right, so if you take 803 divided by 862 and then multiply that by 100%, that's going to give us our percent yield, which that comes out to be 93.2%.